So the next step is then to react our molecule with the protecting group on the oxygen from the alcohol with the organometallic reagent. And here we have a lithium-based reagent, which is a really strong nucleophile. And I'm just going to label this as R for ease of use, just because I don't want to write that out until the end. So because this is a really strong nucleophile, and we have a very electrophilic carbon right here, this basically acts as a carbon anion, which is a really strong nucleophile, and thus this will come in and react here, giving us H3CO. Giving us our first tertiary intermediate. Because this OCH3 is a relatively good leaving group, or it's the best leaving group here, some lone pairs on the oxygen will kick back down to create the really strong carbon-oxygen double bond, and then by doing that it will kick out OCH3, leaving us with that. And since there's two equivalents of this, we just do the same thing again. Strong nucleophile, electrophilic carbon. This goes there, kicks up the double bond to the oxygen, giving us our second tertiary intermediate. And here, there's no good leaving groups for the oxygen to recreate the double bond with the carbon for. So no leaving groups exist. And thus, that's the end of the organometallic reagents. And here we can add the acid. Is that right? Yeah, the cold and dilute acid. Just to protonate this oxygen. And that leaves us with our final product, which now I will redraw. That's this carbon. Yeah. Leaving us with this product, which is the result of two equivalents of an organolithium reagent and then an acid to protonate the oxygen. And then from here, what happens next? Yeah, so from here we have to remove this protecting group. And to do that, we're going to add some acid. This is acidic. This oxygen has lone pairs, thus it can take away these protons, leaving us with this. Oh, plus water. And because this is a really weak bond now, because this oxygen has a positive charge, it will break and form, and that bond will form lone pairs on that oxygen, leaving a carbon, or leaving us back with our alcohol. All right. Yeah. Leaving us back with our alcohol that has been that has had these two groups attached onto the molecule. We're not quite done yet because we have this unhappy carbocation, which is also resonance stabilized because it has the lone pairs on oxygen next to it. And then water will come in. This is a really acidic proton because it's it's one carbon away from a carbocation, which makes it, which gives it a pK of a negative number, so it's really strong. So that will take that, we'll reform the alkene. And we're left with our final product and another happy molecule, plus H3O plus.